you can see my screen. Hello.
Yes. Yes.
Yes,
Yes.
yes, 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 yes.
Yeah. Like when you open LTSpice, you will get a window like this. And start working on a project, just click on this new schematic, and you will get a window like this. Like here, you can put your design your circuit, add a components, add components, remove components, like all those things you can do here. Like after clicking this new component, let's just familiarize with this toolbar. And here you can see the various components. These are the most used ones, like ground, and this is a resistor, and this is a capacitor, inductor, diode, and this is the important one. Like double clicking on this will give you the whole list of the components. Like here you can see all the ones, and here these are some sections. Like in this square brackets, you can see some sections. Like when you double click on this digital, you can see XOR and all those things that are beyond that are specific to a thing. Like that's the thing. And let's just go, like let me just add some components into this. Like first let me add voltage source, and when we just click on this component, and in this just click voltage, and you can see that your mouse pointer changes to a voltage symbol. And wherever on the screen you can place it, like position your mouse there and left click, and it will place there, and your mouse pointer will still be on a voltage level, and you can place as many as you want, and wherever you want. And after you have placed all the voltage sources that you want, you can right click or you can use escape. Both will work. And if you right click, then the mouse pointer will change back. Now we don't need this much. So if you want to remove a component, just use this scissor tool. Like we won't be deleting anything from here. We will just cut it off. Like that's enough. Like we can cut this one, and this one off. And now let me add a resistor. Like it's the same thing. Just click on a resistor. You can also use keyboard shortcuts for this. Like if you click on R, your mouse pointer will change to a resistor. If you click on V, it will change to a voltage. You can use that too for easier purposes. Like just let me just design a circuit here. Like let me just place a resistor here.
Ben,
And,
excuse me,
yeah,
Ben. Where
yeah.
can we find this keyboard shortcuts? Like, where is it listed?
You can see it in here. Edit. You can see all this. Like here in it is given.
Okay, yeah, clear. Yeah.
Okay. And after I have placed two resistors here, and now let me just put also let me just put a ground too, like a ground here and a ground here. And after this, the main aim is to connect all this. Like if you want to design a circuit, we want to connect. Just click on this pencil. This is the wire. This is the option to select a wire. Just click on this, and you can select. If click on this square, and you can, after clicking, just release and move the mouse anywhere you want. Like anywhere you want the wire to go, just move your mouse there. And after you reach till where you want the wire to go, just left click again, and the wire will be there. And from that point, the wire will go on and on until you click the right click your mouse, until that the wire continues. Like you can go here, you can bend, like go here, anywhere you want. Like I just want to go here, then click left click again, and a wire comes there, and I will continue here, click here, and that ends it. Like a circuit, when a circuit is completed, it ends. And just scroll. You can use a mouse scroll to zoom in and zoom out. Let me just zoom out a bit. And after that, let's just connect this. Click on that square and click on this, and it connects. It is connected. And let me just join the circuit to the ground.
Ben,
and the circuit is complete. Yeah.
Can you reduce your pace? Like, can you go a bit slow so that everyone can design the circuit by the meantime?
Yeah.
Okay, like, yeah, give some time for designing the circuit.
Okay. Yeah. Sure.
Like, give a 1 to 2 minutes so that everyone.
Yeah. No problem.
Pace up. Yeah. Okay, guys. When you have when we have completed a specific circuit, we will give you time to design that circuit by your own. Like,
and if there are any doubts while like when you are designing by yourself, if you have any doubts, just come forward. Like you can unmute yourself or type it in the chat. Anything that's comfortable for you.
Yeah.
Where is the voltage source? Voltage source.
Voltage source. Yeah.
Like there is a thing called component here. Like beside this hand symbol, there's a thing called component. Double click on it, and towards the end, there's voltage. Like V, it's in the alphabetical order. Towards the end, there will be a thing called voltage. Like
Yeah, okay.
double click on that, and
So
your mouse pointer will change to voltage.
the list, we can select the list in the by clicking on that.
Yeah, component.
Yeah, okay.
Component.
I think that
Ben.
looks like the AND gate.
Dude, now in case you draw the voltage and resistors, and
Yeah.
you forget the diodes, but you have connected the circuit, so that time how
Yeah.
you add the diode?
Yeah, you can just use this cut, and you can cut this wire, and click on like this is the option for diode. And one more thing I will explain right now, like this is the diode, and we don't want the diode to be like this. We just want to rotate it. You can click Control R, and it rotates by 1 degree, or you can use this option here. Like this is a mirror,
mirror
so it
option.
rotates 180 degree, and this is rotate 90 degree. This is to rotate 90 degree, or you can use the controller shortcut, keyboard shortcut.
Which is the diode option?
That option is
Is it
this
near
one.
the-
This one,
Okay. Okay.
just beside the component. And after I have placed like this, then I can use the wire option to connect this diode to the circuit.
Okay.
Now let's just design a simple circuit. Diode I will explain later.
Guys, have you reached till this point, like where we have stopped right now?
Can you show wiring once again?
Ben,
Wiring again, like
wire.
wiring again.
Yeah, wire.
Just click on this pencil, and wherever you want, like if you want to connect this voltage, then click. There's a square will be there. A square icon will be there, close to the voltage. Like click there, and after that, wherever you want, just click there and move it in any direction you want, like north, west, south, or east, like wherever you want. And after you reach the destination you want, just left click again, and a wire will be there. And if you are when you are done, just right click, then it will go. Sai, did you understand? Like, should I explain it again?
Yeah. We have to press the left click continuously, right?
No. Left click is continuously, don't have to. Like you can just at the starting point and the ending point. That's enough. In
If
between,
you have to bend the wire, then you can use the left click. Okay.
yeah.
If you want to bend the wire.
Okay.
Only straight wires are possible in this. Actually,
There's no
curved
bending
wires are
option.
not possible. Yeah, curved wires are not possible.
And one more important thing, whenever you connect the wires, try to extend it up more. Don't make it very short.
Yeah.
Actually, why do we do like that? Why do we extend it like that?
So that we
there's
can we can label and get the output. Yeah.
Decide
yes.
output.
Okay.
In
Desired
case you have to
output.
name something and the wire is short, it will create confusion. So it's better you extend it a little bit more up.
Okay.
Yeah.
Got it.
Like labeling is, I will show this after this. Okay.
Oh yeah.
Yeah.
So I guess everybody has reached somewhat like this, somewhat a circuit like this. I think when we can continue.
Shall I move on? Okay.
Should,
Yeah.
Like wait. Is everybody comfortable with this? Yeah. Have you reached this point?
How do we remove components?
Yeah.
Like click on this scissor icon here. This scissor icon here.
Okay.
That can be used to cut. Like just let's remove this wire. Like I can click here and the wire is removed.
Then
Okay.
how to change the resistor position after wiring?
You can cut it and just put a new resistor.
Moving is not possible.
Then can I add one thing?
Up.
No, there's no need to cut. You can drag that.
Move. You can drag also. Like
You can
this option
drag
is
and
there. You
select
can
the
drag. Drag and select. Like move.
There just a right side, I think. Drag. Move button is there.
Move button. This
Yeah.
hand.
Yeah.
That this move button can be used for more than selling a number of components, and you can move that whole component section. Like just let me put some like I put 1, 2, 3, 4 resistors here, and I want to move this whole circuit to some other place. I can just click this move icon, select this 4 resistors, and I can move it anywhere I want. Like if you design a whole circuit and you just ran out of space, you can click this move icon, select the whole circuit, move it to some random other place and place it there. Like that's what the move icon can be. You can select more than one component and move. And moreover, after you place a resistor, you can't rotate it. That's a problem. So what you can do is you can select using the move tool and then rotate. Like you can move it here, like rotate anything you want. You can select it using the move tool. Okay.
Remember, like whenever you use the move, if you like in a wired situation, you just use a move. You have to focus only on the resistor. Otherwise, you won't get
Otherwise
able to move the resistor. The wire will move, the naming and all will move. So focus only on the resistor and cut it out.
Yeah. Try to click on the resistor while doing that. Yeah.
Okay, if you have any more doubts, you can speak up, or else we can continue. Okay.
Okay, now after we have designed the circuit, we have to like give it values, right? Like here it's V volt, R volt, R volt, and also this voltage has been named as V1, and this resistor has been named as R1, and this resistor has been named as R2. Like if you want to change the name of a particular component, uh, put your mouse pointer above that component and right click, and a window like this will appear. And here you can change the name. Like let me just change it to VN. Yeah.
Ben, after you do each procedure, give them time to replicate the same one in their simulation. Okay?
Yeah.
Because
Like
I face trouble when you go a little bit faster, okay? So that I can cope up to that. Yeah. So after you do something, you try repeating the same procedure again. So we can all do it together.
Yeah, sure. You
So
can name it.
Second.
Okay. Like if you want to name a component, like rename a component, any component that you want, you just have to put your mouse pointer above the name of the component and just right click. And a pop-up window will come like this. And here you can change it to any name you want. Like let me just change it to Dan, I guess. Dan. And this is my Dan voltage. And okay, you can rename any component that you want. If I want to rename this resistor, then I can right click this and I change it to whatever I want. Like I can change it to R2 and the next one to R3. Anything. The same procedure. Just put your mouse pointer on the top of the component that you want to change, on the top of the name of the component that you want to change, and just right click.
Okay, Ben, we are clear already. Yeah.
Ben, let's make it simple. Don't put the R1 and R together. We'll just make it only R1 and R2 for the entire resistor.
Yeah.
Because we won't be using the other R at all.
Like which one?
The two resistors
one
are
resistor.
there, right?
You mean? Yeah.
Yeah, just make both the resistors. One of them R1, other one R2. Only the plain Rs.
That R is actually the value. Like we haven't entered the value yet. That's why there's an R there. Like it's a variable. Like I show that. If you want now the voltage source we haven't given a value to this voltage source. Like if you want a 5 volt
It's like
battery.
unit representation. Like
Unit representation. Yeah. Like if you want to give a value to a particular component. Let's say for example, I want to give a value of 10 volt to this voltage. Then what you have to do is let's move this mouse cursor on the component so that it changes to this hand symbol. And after that, right click. And a pop-up will come like this. And here you can enter a value that you desire. Like I am right now entering 5 volt. And after entering the value, click OK. And the V will change to 5. Now this voltage source has a voltage of 5 volt. And similarly, like that, I can also hover over this resistance right here, and I can, after the mouse has changed to this hand symbol, I can right click, and here too I can change the resistance to any value I like. And here one thing, like, have you reached till here?
Any doubts up to now, guys? I'm okay with this. Anything you want to ask? Ashwin, do you have something? Yeah, he
No,
has
no, no.
shared a jam file with us. Ben, have you seen that?
Yeah.
A link
Yeah,
he
I
shared.
don't know what
Sorry,
that
that
is.
was mistake.
Oh,
Yes.
okay. It's all right. Yeah. It's all right.
All right. Yeah. Like, can I continue? Yeah.
Yeah. Of course, yeah.
And like similarly, I can also change the value of this resistances. Like just hover over till it becomes
Left,
a
right, left.
hand symbol, then right click. And here one thing you have to notice is like the resistance, the number value that we will enter, it will be in ohm, like the SI unit. So like in this circuit, I want to give it 1000 ohm, that is 1 kilo ohm. Like then what you can do is you can type 1K for kilo ohm. You can give 1K for
We
1
can
kilo
also
ohm.
type 1000, right?
Yeah, you
If
can also
want.
write 1000, but for simplicity, we can write 1K so that it's 1 kilo ohm.
Yeah, okay.
Then click OK. You can also give the tolerance and power rating and all, but it's not necessary here. Like we can give the resistance value 1K and click OK. And the R changes to 1K. And similarly, I can also change the value of the second resistance. Here I will give it 2K and click OK. And that will change the value of the resistance to 2K. So now what I have done is I have designed a circuit that has a voltage source of 5 volt and two resistances in series, which has a resistance values of 1 kilo ohm and 1 kilo ohm and 2 kilo ohm. Guys, are you okay with this? Any doubts?
Bro, how to make it a micro ohm?
M.
Ben, it's not M, it is
M
U.
for milli, right?
U.
Yeah. Micro is U. It's
Nano
mu,
N,
right? So,
micro U, milli N.
yeah.
That's
Yeah,
it.
U for micro. Milli is N. Sorry, milli is N.
Okay.
Okay. Okay. Yeah, we can.
Now I just want to know what the circuit, like when I connect this, like in real life, what happens, I want to know. So that
Okay,
for
guys,
that,
one more thing I'd like to add is the ground we have given here. Actually, what this means is we are assigning the potential over there to 0. Over the negative terminal, we are giving it as 0 by grounding the thing over there. Okay.
yeah,
The wire we ground.
the voltage here is 0 and
So
here is 0.
here is also 0. So current flows through a closed circuit through the ground. Okay.
Yeah, like 0, then 5, and this voltage source gives 5 volt across this and this. And a current actually flows. It's a closed circuit, actually.
Closed circuit, yeah. Even if you don't see, so the current is closed, like the path is closed through the ground. Okay.
Yeah. Like if you want the circuit to run, like if you want to know what will happen if this circuit is connected this way, then we have to go to this symbol here. Like it's like a man running and it has a name of run. Like if you click on that, a pop-up will come and like pop-up will come like this. And the first setting is transient, and we can run the simulation on this itself. And one thing you want to enter is like they will ask for the stop time, which is the time up to which the circuit should run. And you can enter any value that you want. Like let me just give it 1 second, like 1. Like as the same unit, you can give 1 U for 1 microsecond, 1 M for 1 millisecond. Like anything you want, you can enter here. Like the unit here is second. For time, the unit here is second. So I am just giving 1 second and I am clicking OK to run the simulation. Like I am running it on transient. So let me just click OK. And this thing pops up. like the basic interface, like have you guys reached here? Let me just zoom in here.
Yes, bro.
Yeah, guys, everyone reached. Like, shall we continue with that?
Yes.
Yeah, we can move on, guys.
The basic interface of LTSpice is you get the result in this tab. Like these are all windows. You can just move it around, resize it, which way you want. You can customize it. The interface of LTSpice is like that. You can design the circuit here. Like
Okay,
this is the
okay.
place where you.
Vaishak is asking what is transient. Can you give that?
Actually, Vaishak, that's all the various ways in which you can simulate a
then,
circuit. Like
hello, Ben. Yeah.
yeah.
A transient means whenever we apply voltage to a circuit, there before reaching a steady state, we sudden change in current can occur. That situation is known as transient. That only
Like actually, what this
second it will occur.
actually what this mode is used is when in a capacitor or an inductor, it will actually initially the current will not flow. Like as time passes, it will take some time to reach the steady state. And to obtain the like I told you that I can specify the stop time. Like if the time that taken for the current to pass might be in millisecond or microsecond. I can enter a value like that, and here you can see 0, 0.1 second, 0.2 second, 0.3 second, and it goes up to 1 second. And if I enter 1 microsecond, like it will be such similar small intervals. And here when I will show you, we can obtain graphs for this. And in a case where we include an inductor or something like that, we can see how the current grows. Like it will grow from 0 and it will grow up to the steady state. And for transient is used for that, so that we can see what the process is happening like in the circuit.
What
Like
is the
that's-
y-axis? Y-axis. What does y-axis indicate?
Y-axis indicates different things. Like if we that's the next part. Like at different times, like we can know what the current is, what the voltage is at a particular point. Like all that will be plotted on the y-axis. I will show you just in a minute. Like have you guys reached here? Like any doubts?
I hope everybody has reached the transient part. Set their stop time and then click the OK.
Then you will get a window like this.
Okay, can we move on? If we get a confirmation, we can move on.
Yes.
Yes. Okay.
And let's just okay. Hello.
Yeah, Ben, you can move on.
Yeah. Like let me just imagine a situation where I want to know the voltage at this point. Like here you can see that the mouse pointer has changed to a symbol of a like a wire, like that multimeter, right? That point you will put on that like simple the mouse pointer will change to. And anywhere on the circuit on the wire you can click to know the voltage at that point. Like if I click here, I can know the voltage at this point. Like if I click there, then the y-axis will pop up and the voltage at that point will be given in green. Like here it is a 5 voltage source, so the voltage that is present at this point of wire will be 5 voltage. That's why I am getting 5 voltage here.
Okay, so is the circuit running now? Is it in the run mode now?
Yeah, it's running.
Yes, it is in run mode. It is in run mode.
So we have given a time stop time like 1 second, right? So it should be stopping after 1 second. So why does this?
And let me add one thing. Yeah, it will be stopped after running. It will be stopped. Then we can analyze whatever is happened. That is
whatever has happened throughout. It will run in a split second. It will run, and we can analyze at 0.1 second what happened to the circuit. Like here in this circuit, the voltage at this point will be constant throughout the run, like 0 second, 0.1 second, 0.2 second. The voltage at this point would be constant. But when we consider circuits that include inductor and all, the current through the circuit might be zero at the start of the circuit. Then at 0.1 second, it will be somewhat higher until it reaches a steady state.
Okay.
The circuit has already run, and we are analyzing whatever happened at each of the seconds. at the times that we specify.
Okay, yeah, got it.
Yeah, and anywhere like and some changes you can come here for your comfortability. Like here the scale is like 4.9194, 4.995. Like when I hover my mouse over here, you can see that it changes to a scale symbol. And when you right click here, you will get the settings for the vertical axis, that is the y axis. Let me just plug in my PC 1 second. Sorry for the interruptions. Sorry.
Yeah.
Okay. Like if you click on that scale option, right click on the scale option, you can see that the settings for the vertical axis appears. Like here you can specify the top end, like the highest point. Here let me just change it to 10 volt. And let's see what happens. Like you can see that the top has changed to 10 volt, the top end. And the minimum is 4.94. Let me just change that too. And I want it to be 0 volt. Then the bare minimum will change to 0 volt and the top would be 10 volt. I can see it here. I will change. Actually it's not visible, but it's 10 volt. Like let me just change to 9. Like it's 9 volt here, 4.5 here in the middle, and our value is 5. And if I want to see like how the divisions should go, I can change this tick. I can change it to 1 volt. Then what will happen is 0, 1 volt, 2 volt, 3 volt, 5 volt, and up to 9. Any doubts?
Once again about that ticks, can you explain once again the tick
like
part?
tick part, what the tick part means is like how many divisions, like on how many units should be the division. Like now it's 1 volt, 2 volt, 3 volt, right? That scale now. Tick actually means is the scale of the graph, scale of the y-axis.
Okay.
Let me just change it to 2 volt. Then 0, 2, 4, 6, 8.
Okay,
Like
yeah, got
the
it.
scale
Yeah.
of the graph, that's what it changes. Like scale of the y-axis.
Y-axis, yeah, got it, yeah.
That's the thing. Like that you can change. And here let me just change it to 1 volt, like so that it's our 5 volt is visible. And if I want to know, like that's the voltage that will in this wire. Anywhere you click, it will be 5 volt. And let me just click here. Like I want to know what's the voltage at this point between the two resistors. Like some of the 5 voltage might have dropped at this resistor and the voltage might have decreased. Like that's what we are expecting. And let's just see, like if I click here, then I will see that I will just get a new on the same graph. Like the problem is that I already clicked here and that was already on the graph. That 5 volt was already on the graph. So over that graph, the voltage at this point also get embedded. That's why I am seeing two things, like a blue line which indicates the voltage between the two resistors and a green line which indicates the resistors above that. So if I want to see only the resistance between the resistances, then what I can do is I can right click. Like here there is a heading. I know it's really hard to see, but here there is a heading that shows, like you can see it in your own LTSpice window. Like here there will be written V, and in bracket it will be written N001. Like can you guys see that?
Yes,
Hello?
yes, we can see that.
Yeah. You can right click. Let VN001 is our initial, like where we clicked initially, and that is 5 volt. And now there is one more thing, like VN002, and that's a point between the two resistors, like where we clicked. Like if you want to see only the voltage between the resistors in our graph, we can click on this initial one, that green one, and I can, on right clicking, I will see a window like this. You guys can see, right?
Yes, yes.
And you can delete this trace. Like every single thing that I add to the graph, it is called a trace. Now I want to delete, just click on delete this trace and it disappears. Like then you can see only the voltage that has been between the two resistances. Then you can right click on the graph, anywhere on the graph, and you can zoom to fit, and it will adjust accordingly, like to the value between the resistances. You can just right click and click on zoom to fit, and it will arrange accordingly. Like, have you guys tried, like, any problem?
I found it. It's all right. It's running smooth. Yeah. What about others?
Yeah.
Yeah.
Ben,
Doubts?
so now what you have done is only the voltages, right? Not you didn't touch the resistance part, right?
No, not. I didn't even touch the current and the resistance part. Like
Okay,
resistance
it's just
remains
only the
constant,
voltage.
but the voltage. Like if you click here, the voltage. Like you can click at different points to know the voltage. That's what I am just saying. And to know about the graph, the scale, and all, I am just using the resistance. Like similarly, you can see the current too. Like if you want to see the current, like any more doubts? Like, can I move to current?
Yeah, move. I think everyone is clear, right?
Yeah.
Yes, continue.
Yeah. We can continue. Yeah.
Yeah. If you want to, like, anywhere on the wire, if you click, you can see the voltage. And to find a current that passes through a resistance, what you have to do is you can hover over the resistance symbol. And when you hover over it, the mouse changes to another symbol. And here I can click on, when I click on this resistance, I can see the current value. But here what happens is the current is shown on the right side of the y-axis, because we are trying to, like, initially we tried to measure the voltage, and now we are trying to measure the current, so it overlaps. So what we can do is we can delete that trace, that initial voltage that we measured that was between the two resistance. Let me delete that, then you can see. And when you click zoom to fit, like, it arranges completely. Like I can zoom in, like the value comes between 1.6 and 1.8. So what I can do is I can change the minimum bottom to 1.6, 1.6 milliampere, and the top to 1.8 milliampere. And when I click OK, I can see that. Now let me just change the tick to 0.1 milliampere, and 1.7 is here. If I go above that, 0.01 would be too much. Let me go 0.05, I guess, milliampere. If I go like that, like you can see. And if you want to, like, the exact value, you want to obtain the exact value, what you can do is, like, the heading, right? IR1, you can see, right? IR1, the heading, right? The heading in green color. If you click on that, you will just get a pop-up like this. And this has the exact value. Like, the horizontal is 499.71182 millisecond, and the current at that point would be 1.6667 milliampere. Like, you can get it accurately. Any doubts? Like, can you people see that? Like, did you get it?
Okay. If we are gonna change the time given in that box, will we get the current at that point?
Yeah. Let me just change it. No, it's not changeable. Like, if you click on here, like, it's not changeable.
Okay, so
In the middle.
what this does is it gives a current that is being shown in the middle, or does it show the maximum current, or what does it show actually?
I think it shows the maximum current. I haven't tried it with this inductor circuit.
Okay.
Like, to get the actual value, you can actually click here. Like it shows the actual value. If it's a constant current, you can see the exact value.
Exactly.
Otherwise, you can change the tick and the scale of the y-axis so that you get the exact value. Like I can specify the bottom as 1.65 milliampere and the top as 1.7 and
7,
change the change the tick to 0.001. Then
Okay,
you will
so
get
we'll
a
get
more
exact.
accurate value.
Accurate value,
Like
yeah.
I can see. Yeah.
Yeah.
That can also be done. Like
Yes.
to get.
Got it.
Yeah. Yeah. That's how you can find
Okay,
the current.
guys.
Like
anything you find difficulty till here, like something that
any
you
doubt,
couldn't
no
access?
problem at
Yeah.
all.
Yeah. Okay, let's give them some time so that they can reach here.
Yeah.
Ben, can you explain once again how to measure this current?
How to measure the current that is passing through a resistor, right, Ashwin?
Yeah.
Yeah.
Firstly, we measure the voltage, right? A
Yeah.
pen-like thing had appeared.
Yeah.
How
And
to convert
to
that
measure
the current?
like when we hover over the wire, anywhere on the wire, we will get a pen-like symbol, right? And
Yeah.
when we hover over the symbol of the resistance, like when we hover over the symbol of the resistance, you will get another symbol, right?
Okay.
Yeah. Then click. Then you will get what happens, Ashwin. What happens, I think, is like you just have to delete the previous trace, which where we measured a voltage, right? If you delete that trace, then the current and click on zoom to fit, then it will fit accordingly, correctly.
Now, can you take a voltage and then show him how to delete the trace? Deleting the trace. Yeah.
Let me just take the voltage between the two. Like now a voltage appeared. And actually the problem is they are almost of the same value. Let me just take the one here. And here the voltage is marked here, 3.3. The voltage is going here. And the current is the green one. And the voltage 5 volt is the red one. Like whenever we click at different places in the circuit, more and more things are added to the same graph. Like new graphs aren't being created, but are created on the same graph. That's the thing. Like you can measure the current from here. It comes between 1.6 and 1.8, and the voltage. Like I will show another thing after this. Then it will become easier for you to track down the different things and all. Like you can. Now it shows V and bracket you see N001 and you don't know which one is that. Like you can rename that easily. Like Ashwin, did you get it? Like how to get the current? And like to delete this, right click on that heading, right? Like V bracket N002, just right click on that and just click on delete this trace. And that changes to then it automatically changes to the current window. And click on zoom to fit. Like here it automatically changes, but if there is a disturbance, just click on zoom to fit and you can see the current. Ashwin, is it okay?
Yes, Ben. Is there any possibility that we can make a new window for representing each graph?
I haven't tried that yet. I think we can create a different window. Like here, new window you can create, and on that I haven't tried it yet. I will just Elias, can you look into it?
I've been maximize the window. Right, top right side. Yeah.
Actually, what happens? Can you see? Is it visible?
You can expand that window. Yeah.
Yeah. Actually, why I didn't do is because I have this Meet Google is sharing this, and I might get it is a little difficult for me. That's why I didn't expand that. Now it's visible, right?
Yes.
Yeah, it's visible.
Like, is it okay right now? Can I move on?
Creating the new window, that I think that you can look into later. Maybe you don't know. Okay. Like if you do a search in YouTube, maybe we are just trying to cover the basics here. So we also don't know much about this. So Maybe Alias, do you know how to create a new
Alias,
voltage?
if you can just search in the net and you can explain, right?
Yeah,
Right
towards
now,
the end
before the
maybe.
meetings.
Yeah, before the
Towards the
meetings.
end.
Yeah.
Okay.
Okay.
Sure. And if you want to, like in some courses, like we want to know the voltage. You saw how hard it is, like VN001, N002. Like we don't know what is what and what is not. Like it's really hard to trace all this. So one thing that we can do is, if we want to find the voltage, let's say at this point, like we want to. That's why initially someone said that let's just extend this wire up to here. Like this is the point at which that I want to find the voltage. Like in the question it's asked, like what is the voltage at this point, specify the voltage at this point. Then what I can do is, we can just extend this, and here there is a icon called label net, that a symbol with a placard, right, a placard type symbol and an A in the middle, and its name is label net. Can you guys see?
Yes,
Beside,
yes.
just beside the ground. And when you click on that, and you can type like any name you can to the label. Like in the bracket we got N001, right? Like that, if whatever you want, like let's just name it result. Like this is the result voltage that is cast in the question. Like let's just type it result and click OK. Then we can place it anywhere on the, like I just want to place it here. Like then when I run it and I click on this, then I will get, I have to run it again. And when I click on this, I can get the voltage at that point. I just have to click on result, and then I can get the voltage at that point. And one more thing, in the graph, in the name, it will be displayed as a result. I know that you can't, people can't see this, but like just try it on your own PC. You can see it there, because I can't zoom in more in this software. Like I tried it, but I couldn't find it. Like, can you see, like, yeah.
Now we're going to explain only about the graph here. That time you can just maximize that screen.
This screen.
Yeah, maximize it.
Yeah.
I think now it's better.
Now is it visible?
Others
Now
can
is it
zoom
visible?
directly from the Gmeet. Others can zoom directly from the Gmeet.
Oh.
Screen sharing,
Okay.
you can.
Yeah. You can see, right, V, and in the bracket there is a result. So if more than one voltage is there, like in this only one is there, but I just added one label only. But if there are more than, like I want to find the voltage at more than one place, then I can name all the different ones, like V in, V out, VCC, V emitter voltage, like anything I want I can label, and I can find all this in the single graph. I just have to, like according to the color I can know which is which. Like V result is blue, and what is the voltage? 5 volt. I can easily find from the single graph itself. I can find, like if the values are little bit close and you can't distinguish between the lines, you can change the scale. You can easily change the bottom and the top, and you can change the tick accordingly, so that you can get an elongated or enlarged, or like you can it's completely flexible. You can change it any way you want.
Yeah, got it. Clear, Ben.
Yeah. Shall I move on? Like it's really helpful if you want, there is more than one component and you want to find the voltage at different places and all. Like, have you guys understood till now?
Yes, yeah. We can label the thing, the place where we want to find the voltage, and then clicking on using that. Yeah.
And when we run the thing, we can just click on that label and we can get the result there. Like we don't have to find the correct place, like pin, and we don't have to. Yeah. And one thing you can do is, like if you want to find the thing at this, you can zoom in, find the point, put a label here, and just zoom out and click on the label. You can place the label here, or you can place the label here. No problem at all. And just have to connect it to the wire. That's the only thing. Like you can reduce congestion a lot. Like when it comes to bigger and bigger circuits, like you can just place all the labels here. and you can just have to like connect all the things to here. Then it reduces a lot of congestion. Like you don't have to put all the labels here, like so that the circuit is more visible and congestion can be reduced. You can zoom, like scrolling can be done to zoom in. Like I am zooming in right now by scrolling on the mouse. You can just zoom in and zoom out, and you can select whichever place that you want, and you can zoom out. That's clear, right?
Yeah, Ben. Yeah, you're clear.
Yeah. And another thing, like let me just, now we just gave a constant voltage source, like a battery, which gives constantly 10 volt or 5 volt or whatever volt that we specify, it gives, right? It gives that. Now let me just, if you want a, like, let me just remove this. Let me change it to one resistance. Like we don't want to have more than one resistance. Let me just remove that. Connect this. And you guys changed it, right? It's okay, right?
Yeah, Ben. I changed it. Yeah.
Yeah. Let me just maximize this window right now. Like we don't need the result window right now. And
Yes,
what zoom in also. Like what we can do is, when this is a constant voltage, like right. Let me just stop the stimulation too.
Can you also mention how to stop the simulation? What did you do?
Just close that that graph window, right?
Okay,
just close that.
Just close that. Okay.
Yeah. When you close, the simulation automatically ends.
Yeah, okay.
And if you don't have, you can end it also, like the stimulate option is here. The stimulate option on the top.
Yeah.
You can click that, and the pause and halt will be there. And shortcuts also Control P and Control H. Like if you are running a circuit for like 1 hour, like you can specify a time, right? Like 1 hour, and it only reached 1:30 minutes, and you just have to go for dinner. You can pause it, and you can come back and run it afterwards.
Oh, okay.
Yeah. And like our cases, it's just 1 second, 1 millisecond. That's all. Like I'm just saying. Yeah. Now when we click, like when we want to change this voltage of this voltage source, we just hover over it. When the hand appears, we just right click, and we get an option to enter a DC voltage value that we want. But let's just imagine we want to give an AC voltage source, like a sine wave or a square wave. Like if you want to enter something like that, what we have to do is, like if I am going at a speed phase, or if I am going fastly, just tell me, okay? Like I am a little bit nervous too. Sorry. Like I just have to click on this advanced option here. Like if I click on that, then I will get a whole new window where I can spray everything. Like if I want to design a sine wave, like a sinusoidal waveform, like sinusoidal input, like AC voltage that varies sinusoidally, then I can click on this sine option here. And when I click on the sine option, you get these values. The last three are not required for us. Only the four ones are required right now. Like, and the first one is DC offset. And what it specifies is, like, imagine a normal sine wave. It oscillates, the x-axis is at 0, right? It oscillates from 0 to 1, 1 to 0, then 0 to -1, -1 to 0. Like 0 is the midpoint, right? Like here too, we can specify a midpoint. If we want the sine wave to oscillate from 1 volt to 5 volt, then 5 volt to -4, like that, like we want to oscillate, we can specify this. And in most cases, we just put it at 0. Like that's what I just explained, like what we use the DC offset for. I will show you with all the examples, like I will just change the DC offset, amplitude, frequency, all this I will change and show you. But this is the thing, like where we want the midpoint of the sine wave to be. That's what this happens, like to oscillate from 1, or in normal sine wave, it's 0, right? And we can specify from where this one to, the midpoint from which this should oscillate. That's the DC
yeah.
offset. And the
DC offset,
amplitude is the peak value of the AC. Like it's a 5 volt AC, 6 volt AC, like peak value AC, that will be most probably given in the question. Okay, like the voltage source, like when we give 5 voltage DC source, like 5 voltage AC source, that's the amplitude. Let me just give 5. And the frequency, let me just say 1 kilo ohm, and for that I am just entering 1k, and the frequency is in the unit of frequency is hertz, and that's why I said 1 kilohertz. And the time delay, what this time delay says is like uh, like this DC offset is used to specify the x-axis, that we can say. And this time delay is like I only want to give the start the giving the AC source from 1 second. Like I am running the let's just imagine that I am running the simulation for like 10 seconds, and I want the circuit to start functioning at the 5th second, and I want the circuit to stay still, and I don't want the voltage source to give any input till the 5th second of the whole 10-second simulation that I'm running. I will specify a time delay in seconds or unit, any unit that you want, you can specify. And if I enter 1, the voltage source will start giving the voltage source will start giving the output only after the delay time that we enter. After the 1 second. That's the we don't want any delay, so let me just change it to 0. And the frequency is 1 kilo ohm, amplitude is 5 ohm, and the DC offset is 0. And after you have specified these things, like these three are not necessary for our understanding. Like it's a higher level thing, and I think this is cycles, and theta is the sine theta plus phi, that theta, like initial phase angle, right? That is not necessary for our initial thing. Yeah. So what we can do is like we can specify these 4 things, and we can click on OK, and we will get a thing like our value changes. Like it is not fixed anymore. Like it's a sign, and this is 0 offset. This first 0 indicates the offset value that we specified, and it's 0 offset, and the amplitude value is 5, and the frequency is 1 kilo ohm, and the time delay is 0. That's what this bracket values indicate, like in order. It's in the same order that we fill in the thing. And let's just see what happens when we run this simulation. Like we are expecting a sine wave, right?
Yeah.
Let's just let me just run this. And if I click on or at this point, shit. Like what happened is, we have specified the frequency to be 1 kilo ohm, and
so this is a waveform, right?
Yeah, this is the waveform. Like actually, this is I made an error, and I will say what happened. Like earlier when I ran this, I specified the stop time to be 1 second, right? Like what does the frequency say? Frequency of 1 kilohertz says that in 1 second there will be 1,000 oscillations. There will be 1,000. Like actually what is happening is this, you can see in the graph, this is 1,000 oscillations. That's what happened. So to change this, I can, so I ran it again. Click on this simulate, and click on this edit simulation CMD. Like when you click on this, you can get the initial settings panel
command prompt.
And command prompt. Like here I can mention the stop time to be 1 millisecond, like 1 m. And when I click OK and run, this will change. Like 1 millisecond is too short. Like only one sine wave comes. Okay.
Yeah, I think while taking the reading, one sine wave will be accurate, one proper sine wave.
Yeah. Then I will change it to what? 5 millisecond will be enough, right?
5 milliseconds, or make it 10. 10 is better.
Yeah. Okay, then 10.
Let's see how 10 is. 10
you can try whatever you want. That's the flexibility. Nothing will happen. Like, and when I click on run, you can see that. Yeah.
Now it's better.
Yeah. This is what happens. Like it goes from, our offset is 0, right? DC offset is 0. That's why it starts. Let me just zoom in. Okay, ours it starts from 0 and it oscillates till 5, which is our peak value, and then it goes here, reaches 5, goes here, reaches 5, like it goes like this. And depending on the frequency, like that's the time is dependent on the frequency. Like you guys understood this, right?
Yeah, Ben. Yeah.
Any doubt? This is the sine wave. Okay. Any doubts?
Then can you explain the editing once more to get the command window, the command window that changes the simulation window?
Yeah, just click on this simulation. Like I am currently running this. Let me just close this. You can click on simulate, and there will be an option called edit simulation CMD, like the last one. Just click on that, and the population, the command prompt will pop up. And here you can specify the stop time.
Okay, got it.
For fun, let me just change it to 5 milli. Like, and then if I click OK, and then you have to run it. When you click run, and let me just find what is the voltage at the point that I have labeled as a result. Just click on that, and this is the sine wave. A sine wave which oscillates between +5 and -5, because that's the peak value that we specified, and the frequency is 1 kilo ohm, and the offset value is 0. Like, then let me, for fun, let me just change this offset value to 1. Then I can, oh, that's the current. Let me just stop the stimulation. Change this offset value to 1. And so run it again.
After each modification, you have to run again, right?
Yeah.
Okay.
And let me just click. Like, see. Now the offset value I specified it as 1. Now the graph starts at 1. And it oscillates between, like, see, from 1 it goes 5 spaces up. And it reaches 6. And from 1 it goes as 5 spaces down. Like, our oscillation is 5. Starting point just changed to 1. That's the thing. That's what DC offset says. And that's one thing. And the frequency, if I change, then nothing much we can't understand, because it's too high a value, right?
Yeah.
If I change this 1 kilo ohm to 1, then I will just see 1 sine wave in a volt second. Like, that's the thing. 1 kilo ohm, like, that's why I have to change this to 5 millivolt. Like, we changed the scale of the vertical scale, right? Like this y-axis. We can also change the scale of this horizontal axis too. Like tick left, right, and the tick too. We can change here, but normally we wouldn't want it. Like unless we want a specific point in time, we wouldn't change it. But I'm saying that we can change it completely flexible. Like you can change it any way you want, but similar to the y-axis itself. Any doubts?
Yes, like clear, Ben. Yeah, clear, Ben. Anyone else, like you have anything to say? Anything to add maybe into what Ben said?
Like anything to add, or any doubts or anything?
Please ask away so that we can clear everything and we can start doing our problems now, like, for the first week. Yeah, I think after this we would be able to start doing the first week problems.
Yeah. After this, I will show a square and I will show a diode. Like that would be pretty much it, right? Yeah, that would be enough to solve the experiment. Initial experiment. That would be enough to finish the first experiment, I guess.
Yes.
Yeah. Like let me just stop the stimulation and just enlarge this. And now it's a sine wave, but now I want to get a square waveform. Then what I can do is I can just hover over this, and when this mouse changes to this hand symbol, I just have to right click, and here this pulse option is here. This pulse one, like I just have to click there, and another set of options pop up. And this is a little more not complicated, but some more things we want to specify. Like this V initial. V initial is, let me just take a square waveform, then it would be easy to understand. 1 second. My screen is visible, right? This tab.
Yeah, visible. Yeah.
One
Yeah,
second,
Ben,
one
yeah.
second. I will share
But
again.
now it's gone. Yeah.
I will share again. My entire screen is visible right now, right?
Yeah, it's visible.
My entire screen is visible right now. Okay. Let me just change it to, okay.
Yes.
Now you can see a square wave, right? And
Yeah,
actually, we will be creating a square wave like this. Okay. And here we can see the V initial. They are asking for the V initial. And what this V initial says is like this value, the low value, right? The low value is the V initial value. Like let's just say it's 0. Like we want to create a square wave that like the same like this one, the given in the figure, right? A one given similar to the figure. So let's just specify the V initial to be 0. Okay, and the V on is the high value that's specified here. It's 1, right? So let's just put it as 1.
1.
Actually, what I got confused is this time delay and time on.
Yeah, okay.
Yeah, actually what happened is like time delay should be the time that we should wait after this square wave should be given, like as in the sine wave. As in the sine wave, this time delay is the time that we should wait after the voltage source gives this square waveform. And T rise and T fall for all the square wave questions, you can put it as 1n. You can put it as 1n. In ideal case, it should be 0. Like it should rise as in 0th second. Like no time it should wait, but it's showing some error. That's why they are preferring for 1n, I guess. Like I don't know why they say 1n, but they say for square wave just put 1n.
Yeah, if we are taking 0, it is coming some slant.
It is coming. It is coming from some slant. Actually, there shouldn't be any slant, but there is. Like that's some error, I guess. Software. Like so they are telling us to put some low time value, like 1 nanosecond. 1 nanosecond for rise and 1 nanosecond for fall also. And T on is the time that the waveform should stay at high and the waveform should stay at low. And here we have specified it as 0.5 millisecond. That's why when I put it as 5 seconds, so much square waves came on. Like it goes up and down at 0.5 millisecond interval. And the time period is also 1 millisecond you have to put. Like time period says the time after which the square wave should repeat. Like after 1 millisecond, like T on is for 1, like at high it should say 0.5 millisecond, and at low it should stay at 0.5 millisecond. Should stay for 0.5 millisecond, and high and low both takes 1 millisecond, and that's the period.
1 millisecond is the period. Okay.
Yeah. Understood, right? Like for low, you have to stay like at low for 0.5 millisecond, and at high also you have to stay at 0.5 millisecond, and the period then comes out to be 0.5 plus 0.5 1. You can also change this, but to get a uniform square wave, that's what I'm saying. Uniform, like high, low, high, low, high, low. That like square wave, if you want to get, just multiply the T on and just put the.
Guys, if you have any doubt with the inputs, you can ask now. Okay, so that we can move
any input, any explanation, or I just
what's the stop time? What's the stop? One asks, what's the stop time?
Like okay, what's the stop time? That's for the simulation. Okay, let me just close this. Like here, just understand that 0.5 millisecond we are saying. Okay, 0.5 millisecond. So we should, like, when running the simulation, we should also give time that is close to these values. That is close to these values, like in the millisecond range. But if you give 5 seconds, that's too long a period, like compared to 0.5 millisecond. Then we want to be able to know the difference. That's the thing. Like if you click OK and click and edit simulation command, you will get this stop time. And I have entered 5 milliseconds. Let me just change it to 3 milliseconds. And then if M stands for millisecond. And when I click OK and run, and when I click on this result, then I can see that like it stays at from 0, like that t delay, right? T delay here at 0 itself, it starts at high.
Yeah.
You can see, right? It
Yes,
starts at high. But if I want to start at low, I can change this to 0.5, like this t delay to 0.5, 0.5 m, 0.5 millisecond. Okay. Then if I click OK and I run and I click on result, it starts at low. Okay. It starts at low, then it starts at high, low, high, low. Okay.
Okay. Can you explain what you changed just now? What did you change just now?
Time delay. I changed the time delay. Like I will show you once again.
Okay. If the time delay is 0, then it will be starting from the high thing.
It would be started from the high.
Okay.
Like if I like the t on value, right? The t on value.
Time delay is a time after which the signal starts, the voltage source starts running.
At high.
Yeah.
Okay.
At high. Starts at high.
Starts at high. Yeah. Starts at high.
I just for uniformity like entered the same value as t on. Like the time for which it stays on, I just entered the same value. But if you want to start at 0.3, the initially some disturbance, like you can see. Oh, yeah, 0.3. It's not 0.3, 0.3 millisecond. Okay. Click OK. Just run and click on result. And you can see at until 0.3, it stays at low. And then it changes to high 5 volt, then changes, then low 0.5 seconds still remains. Like in the first one only, the time delay of 0.3.
Yeah.
0.3 comes. Like that's what time delay is used for. Understood, right? Any doubts?
Got it. Only for the first waveform, we will consider the time delay.
The time delay, yeah. The time after which the first high should occur. Like that's what time delay indicates.
Okay. Got it.
Any doubts?
Any doubts on the terms that we filled in right now for the pulse wave? Can you take that box again, Ben?
Yeah.
Ben, the cycles.
The cycle should be 0.
You know
So
what
what-
the cycle is?
No, I don't know.
What is the
I don't know what
cycle?
the cycles. mean.
Elias, do you know what cycle is?
Elias, like the senior told me that it's not necessary for us. That's why I didn't say in the science section too.
It's all right. Anything that you need explanation on about the boxes that we filled in?
Any of the boxes, like what I messed up is like I mistook T on for T delay. I don't know what happened, but that's what happened.
Okay.
Yeah,
it's clear. Okay. One says it's clear. You can ask anything. Okay. You're free. Come on. While measuring the current across resistor or source, the arrow.
Just imagine this. We might be in the hostel right now and we are discussing this. That's the same. That's the same vibe. Like
yes.
That's just online.
Now there is one question in the chat box. Can you see that? While measuring the current across resistor, upwards and down, can we change it upwards? In measuring the current across resistor.
Yeah, we can change it. Yeah, sure. Like reverse the direction of the current, right?
Oh, okay. How can we do that?
That's what he means, right?
Yeah, I think that's what is meant.
Actually, here in the resistor, we don't have to specify a current. You just have to rotate this voltage.
Rotate the voltage source. Yeah.
Rotate the voltage. Like it goes from positive to like the current flows right like this, right? Like if there is a similar to this voltage source, you can also add a current source. Like there too you can just rotate this, like if you want the current to flow in the opposite way, just select this using this move one. Just select this, and you can move it, and also you can rotate it.
Ben,
Yeah.
shall we
Yes,
continue tomorrow? It's 9:30 now.
Yes, yeah.
There are girls also inside this meeting.
Okay, yeah.
Yeah. No problem.
I think
yeah,
we can.
Sure.
Okay, guys. I think we just have to discuss what all
Diode.
do we have.
Diode and op-amps. Diodes
Yeah.
and op-amps. Okay.
Okay, diodes and op-amps. Ben, can you cut the part where we made a mistake and then do
Upload.
something?
Yeah. Sure.
Okay.
I can edit the video. Yeah. Sure.
Yeah. Okay. Okay, guys. We will continue tomorrow. Tomorrow with diodes and what all are left, Ben? What do we have?
Op-amps and diodes. Op-amps and diodes.
Okay.
If need means we can add BJT and a MOSFET also.
Yeah, but MOSFET and BJT. We can add if you want, but
but is it there in the theory for us to
for the it's in the theory, but for doing the first experiment, get familiar. We just need the diode right now.
We are just doing the familiarization, right? So
and then tomorrow I will explain how to import that one diode 194007. Okay.
Actually the problem is when we install LTSpice, we won't get this specific diodes that the teacher specify in the experiments. That's a problem. Like we have to import this. Into our LTSpice. Like some AND or non-gate, like that, like simple gates aren't available in LTSpice. In Tinker, you can only use the specific ones that are already available in Tinker. But in LTSpice, you can add another gates that you can like into the module. Like that we will teach tomorrow. Like the time is already. So much. Yeah. Okay. I hope you understand something. Yeah.
Yeah, we understood a lot. Like the basics are all covered. I started from scratch. I didn't know even to complete a circuit. Actually, I did it only today. Yeah, it was the first time opening the app today. I did it today. Yeah, it was really good. Okay. Like
sorry for the mistake I made in the middle.
That's just we can just edit the video there and then
Yeah.
So we will do that tomorrow. We will be discussing the other part where we will be discussing diodes, op-amps, and BJTs. Yeah.
And tomorrow shall we start from 8 to 9?
Yeah. The same time would be okay, I guess. What about everyone?
No, morning.
We can put it in we can put it in the group. We can put it in the group.
Wait. Okay. They are talking about a morning class, but I think we will all be sleepy heads. Like we.
Okay, no problem at all. Like anytime, Dan meet group leader.
Okay. Yeah. That's what. Yes.
Set.
Okay. We will provide the link after doing some editing, the part where we made a mistake, and then
we will post it. Yeah.
Okay, guys.
Thank you for today.
Thank you.
Thank you.